Next up, I'd like to introduce to the stage Dr. Ruopeng An, who is the director of the Constance and Martin Silver Center on Data Science and Social Equity, as well as the Constance and Martin Silver Endowed Professor in Data Science and Prevention at NYU Silver School of Social Work.
Hello, good afternoon, everyone. My name is Ruopeng An from Silver School of Social Work. And I always thought I was a policy analyst, an epidemiologist, and interdisciplinary data scientist, but now I have a new title of meta researcher. Thanks for Liz and Greg. Really, it's my honor to come here and share some of our research findings and interest. And one plug-in that our Constance Martin Silver Center on Data Science and Social Equity in the School of Social Work was established about 3 years ago. And our vision is to chart a shared path between AI and empathy, because we know, at least I don't trust that AI is going to bring empathy by itself. So it needs some push and nudge. And our mission is to leverage data science and AI for social change and equity. So early this year, in February, we had our first conference, AI for Health and Social Equity, that we brought 130 researchers, the deans and directors across the nation to come and convene at NYU to discuss this really important topic. We were fortunate to have President Linda Mills open the speech, and Nobel laureate George Angrist gave a keynote speech. And we are going to continue this next year. In March, we are going to have a fantastic speaker that many of us admire, Dr. Ian LeQuinn, giving the keynote speech. So we welcome all of you to join us next year. And what is agentic AI? Because we are doing a lot of work on data science, especially nowadays we talk about 3 years ago, we talked about large language model, right? Last year, we talked about RAG, retrieval augmented generation. And this year, everyone's talking about agentic AI, AI agent. So really, what is AI agent? Now, think about the large language model is the brain, right? As human being, we have a brain, but that's not enough because we need to learn, right? So that the RAG offers the external knowledge that can be inserted into the language model, so the model is not going to hallucinate, right? Giving you false references. But that's also not enough, because as a human being, we not only have our external knowledge, we can also act, because we have limbs, we have arms and legs, so we can walk around, we can do stuff. And that is called tool calling. So the agent will be able to utilize the tools to do autonomous decision-making and action-taking. So that is the agent. So the agent has the brain, has external knowledge, but also can call tools to act. No, we are doing a lot of research. Actually, I have fantastic doctoral students here who are working with me day and night, doing a lot of exciting meta research. And our goal is try to replicate some of the qualitative analysis using AI agents. We know that traditionally, in this 2x2 contingency matrix, we use qualitative analysis on qualitative data, right? And we use qualitative analysis on quantitative data, whereas qualitative analysis on quantitative data is kind of rare unless you are doing a head count, right? On the other hand, we see emerging trend of using qualitative analysis on qualitative data, text, images, audios, visuals, as you name, right? And that trend is increasing, and we believe that AI agent has a lot to do to improve that aspect. So, for those of you who are doing qualitative analysis, you know how labor intensive it is, how time consuming, how much resources it consumes. One example, I have a previous doctoral student who's now a professor at University of Michigan. She's doing a lot of qualitative research. In one research, she interviewed 150 older adults, 40 minutes each, right? She generated all these transcripts she need to analyze. She ended up hiring 20 graduate students working for a year, but just half complete a thematic analysis, right? Because it is time consuming for all those human hand coding. So we asked the question of whether agentic AI could help in this process. Can AI be used to identify and extract themes relevant to the research questions? Can AI provide detailed descriptions to the themes? Can AI extract relevant quotes from the original transcripts. So those are the questions we asked. And we came up with actually a pretty simple 4-step approach to replicate this type of qualitative analysis, or to be more precise for qualitative researchers, it's called thematic analysis, because we are going to extract themes from individual transcripts. Okay, so the first step, I apologize for this. Probably I used the Mac and this is the Windows. I don't know, maybe it's, well, this is AI, right? No, AI is autonomous. It can do whatever it wants to display, but no, just follow me, right? So 4 simple steps. The first step is, the transcripts are usually quite heavy, right? Very long, very lengthy. 10,000 words, 20,000 words, 50,000 words for each transcript. So we need to chunk the transcript into smaller pieces, say, 500 words or 1,000 words, right? And then we can extract, using large language model, the themes from each of the smaller chunks, right? That is going to be relatively simple for large language model. And then we synthesize the themes at the participant level, right? For example, each participant will have 1 or more transcripts. So we synthesize the themes together on that particular interviewee. And then we integrate the themes together to the starting level, right? So that is our 4-step approach to try to replicate how human researchers would do in thematic analysis. Why if we break it into different steps in chunking the transcripts, the underlying reason why we need to chunk the transcript is, 1, the large language model has a window size, although the window size now is much larger than before. Previously, the model could take probably 500 tokens, now up to 20,000 or more tokens. But still, there's an upper limit. And the second, there is a so-called lost in the middle. It's very much like human being, that if you read a very long book, and then you remember probably the last few sentences, but you forgot what is in the middle, right? What happened in the middle is kind of lost. So large language model have similar problem. So by focusing on the large language model on a smaller piece, it improves the accuracy. And then to extract the themes, we provide the model context, right? Because the model needs to reason, and the agent needs to reason based on the overall architecture of the study, right? In terms of study background, the aim of the study, the interview questions, right? And those will serve as the background when the model are extracting themes. So the themes are not coming from the thin air, but actually come from the aim and objective of the study. And after that, we synthesize the themes at the participant level, because a lot of themes are repetitive, right? And usually in qualitative research, in publication, we usually have, say, sometimes 3 themes, sometimes 8 themes, but usually a finite number of themes, not very extensive, right? Because a lot of themes, sub-themes can be converted and integrated into a larger theme. Some overlapping themes should be deduplicated, etc. So therefore, we need the model to reason across different themes identified, and then trying to synthesize them, integrate them, remove duplicates to form distinct set of themes. And finally, we need to synthesize the themes to the study level. That a study may usually report, say, on average 5 themes. And we try to replicate that. You can actually, as a user, you can define how many themes you want to generate, right? But if you don't take that, the default would be generate as many themes as possible at front, and then through iterative process, we integrate the themes together to form a small number of centralized themes. But how do we really evaluate agentic themes, right? So the study, thanks to OpenAI, who funded our research, we identified a large database consisting of 500 plus transcripts. Okay? And all those transcripts have been used to produce peer-reviewed publications. So therefore, we have the ground truth, right? We can compare the themes we generated to the published articles. Right? So that is served as a golden standard. But still, we need to define some kind of criterion to evaluate those themes. And I think we have a slide on that. So we have 5 human evaluators, all are doctoral students, some are sitting here. And we use a smaller subset of 11 published qualitative public health studies to evaluate the generative themes against the published articles. And we use this 4 criteria to evaluate the generative themes. Alignment, do the GPT generative themes match the manuscript published themes? Succinctness, are the generative themes repetitive in nature or they are distinctive? And qualitative explanations, whether the themes are vague or descriptive. And finally, the quality of quotes, whether the quotes were made up, because we are really afraid that they make up the quotes, because large language models are very good at making up things. So we try to ground the large language model on extracting the original quotes from the transcript rather than hallucinating it. And we use the matrix to assess each of the 4 criterion. The 0 means a terrible performance, and 4 means the themes really match the manuscript really well. Right? Of course, this is a subjective. Well, how the model performs, I would say promising, satisfactory, but still definitely have a lot of room to improve. For example, in this study, by Dupu on physical activity from university staff and students, as you can see that on the left-hand side, we have the peer-reviewed themes published in the articles, and on the right-hand side, you have the GPT generated themes, and they match really well, right? So this kind of theme generation would get a score of 4. On the other hand, well, some others, for example, for the feeding practices, for latex mothers of children at risk of obesity, unfortunately, the GPT model doesn't perform really well, right? So there are some themes that are repetitive and other themes that are misaligned with the peer-reviewed article, right? So this will get a score of 1 out of 4, right? For the succinctness as well, though some studies are performing really well. For example, this one, the explanation of the themes are quite succinct and right to the point. Whereas for this one, the sleeping habits from toddlers at risk of obesity, no, unfortunately, some of the themes were repetitive and the description were not very clear. Okay? And then this kind of study would get a rating of 2 out of 4. Okay? For quality assessment, similar idea. We compare the generative themes in terms of how similar it is in terms of the description and the succinctness to the published articles. And some studies, the GPT model performed really well, others not so well. Okay. And for the, do we have on the quotes? I think this is for the quotes. So sometimes, unfortunately, the GPT model still try to hallucinate and give us a quote that is not existent. In this case, we would get a terrible score. But well, actually, we're working on this, and we have some additional techniques we can bring to the table to further reduce the discrepancy, reduce hallucination, and in a still ongoing study trying to replicate not only thematic analysis but grounded theory, we can achieve up to 92%. My student's not there, but she would agree with me, probably 92% of accuracy, right, in generating codes, if not higher. Okay. So still way to go, but I would say promising. And if we see the evaluation quantitatively, this is the interreliability, the ICC score. As you see, they are all highly significant. And for the 4 criterion, remember the highest score is 4, the lowest is 0. For themes alignment, it achieved 2.75 out of 4. Succinctness, 3.4 out of 4. Qualitative examination, 3.3 out of 4. And relevance quotes, 2.8 out of 4. Right? So I would say satisfactory, but of course has room to improve. So, well, the conclusion is the LLM can assist researchers in extracting themes from qualitative interviews, and the themes are largely aligned with the peer-reviewed articles. But of course, we can further develop this. In terms of the cost and time you spend, as you can guess, this is a fraction of what you would do if you do this manually, right? So a study of 15 transcribed interviews, each with 10,000 words, takes 30 minutes of computational time with a total cost of $10. Now, actually, we can reduce this to about $3. Thanks to the competition between many suppliers, model suppliers, right? The cloud computation cost has been greatly reduced. So think about how much time you can save by using this API. We made the entire API free. You can download from GitHub. You can use it. My doctoral students even create a YouTube short video showcasing how you can use it. You don't need to do any programming. You just provide the data and this will do the analysis for you. But you have to use your own OpenAI or other model API because we are not going to pay for your token use, period. And now what we are doing is try to push one more step, right? You say thematic analysis is easy, right? You can directly use large language model, creating this simple pipeline. But how about grounded theory? We know grounded theory is hard to replicate, but we are aiming for that. As you know, the grounded theory follows 3 steps. The open coding step that you detect and categorize the code directly generating from the transcript. And then you do exo coding that you connect those open coding together to form categories, right? And then finally, you enter into selective coding that you synthesize those categories into a coherent story that is theory-driven, right? So that you basically is a bottom-up approach that you develop a theory, a generalizable theory from the transcript themselves, right? So that is the essence of grounded theory. We are not going into detail about the approach, but you can see it's similar, although each approach is more detailed with a lot of variations. And the first step, of course, is due to chunk and vectorize the transcripts. Vectorize is just a fancy word saying now I'm going to convert those texts into numbers, like floating numbers actually, and save them into a database that can be readily analyzed and extracted by computer algorithms. And then we do one step of open coding, try to extract as many codes as we can possibly generate that are deduplicated and also representative and be faithful to the context. And then we do the exo coding that we cluster the open codes based on their statistical property and how similar they are, and cluster them and doing semantic similarity analysis, trying to group them into coherent categories. And finally, we create this user-friendly web app. Don't check on the internet because we have not open sourced this yet, but we plan to do that. So here, as long as you provide open API key, you provide your transcripts, you can decide how many coders you want, right? You want 1 coder, you want 10 coders, you name it, right? And each coder is going to follow the procedures to do the coding. And you can also choose analytic mode, whether you like interpretive or you like constructionist, that you bring more theory up front, or you want the theory to be organically generated by the algorithm. And you can also decide what model you want to use. And then after you provide all those details, the program is going to run depending on how many transcripts you have. Now we have tested the transcript for hundreds, more than 100 transcripts for a study. So it's definitely scalable, but we are still working on the algorithm to optimize it so that it can run as fast as it could and further save researchers' time. And we are also we are creating our criterion to evaluate the grounded theory in comparison to the peer-reviewed articles using grounded theory. And we have some promising results. And that's shown here. I will not, actually, we have the high code present ratio of 97.6%. So a lot better. You can, still occasional mistakes, hallucinations, but largely we are quite successful. And finally, I'm in the process of publishing a new book, which will come out early next year, called Building an AI-Ready University, a holistic strategy for higher education leaders, that we talk about how, as a higher education, it is our obligation and also opportunity to become AI ready, and how we are going to achieve that. So this book provides a roadmap. And finally, I always show this slide at the end of our presentation. This is my LinkedIn QR code. If you don't mind having another QR code, so connect with me, or if you are traditional, use my email. I would love to listen to your suggestions, comments, and attend in this conference, bond with each other, and think about how we can collaborate. This is my ABC approach. Thank you, everyone.